Hey everybody, Mr. Covey here, and the purpose of this video is you should have done the Desmos now. And what I really want to talk about here is just kind of building your understanding of what exponential functions are and just a few things about them that are going to be helpful. So first, we've talked about equations that look like this. F of x equals x squared, okay? What we're going to talk about now is stuff that looks like this. G of x equals 2 to the x power. Now these look very similar. They both have an x, they both have a 2, and they both have exponents. This is where making sure you know that exponential, which is the type of equations we're talking about in this unit, does not just mean exponents. So they're not just called exponentials because they have exponents. They're called exponentials because they have x in the exponent. Okay, that's what makes something exponential. Its exponent, its power, has an x in it. Okay, so this guy is exponential. This guy, it's a polynomial. This is a quadratic. This is a parabola. Okay, we've talked about this. We're done talking about this. We're talking about 2 to the x. It's used for different types of problems, different real-world situations, totally different thing. Okay, not the same as this. If you need further convincing, just fill out a quick table for x squared compared to 2 to the x, and I'll help you guys. Well, what's 1 squared? 1. 2 squared? 4. 3 squared? 9. 4 squared? 16. So we can fill out this table and see the outputs that we get for x squared, for our parabola. And then for 2 to the x, again, not 2 times x, 2 to the x power. What's 2 to the first? 2. What's 2 to the second? 4. What's 2 to the third? 2 times 2 times 8. 16, 32, 64, 128. And what you see here is, while this one starts out kind of like very similar to this, they look like they're kind of on the same page, the exponential quickly becomes bigger. And if you were to go all the way out to like 100, if you were to plug in 100, well, we can do f of 100. If we do 100 squared, quadratic for a parabola, 100 squared is 10,000. It's pretty big. It's not giant. The exponential, on the other hand, grows way, 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 way faster. So if you were to do 2 to the 100 power, you can go to Google. Look how big it is. 2 to the 100 power is that big. Look how big that number is. Crazy. Okay? It is way bigger than 10,000. Okay? What's my point? These two things are completely different. 2 to the x versus x squared. 2 to the x one grows a lot more. Okay? This thing has 30 digits. It's a giant number, while 100 squared is just 10,000. Okay? In word problems, this makes a big difference. Now, I'll just tell you right now, and we'll talk more about this later, but actually, no, I'm not going to tell you that. I'll tell you later. Okay, let's just look at a couple different scenarios. This is kind of like the Desmos, but I just want to go through this one more time. Similar idea. You get a job after college. First day, you have to decide how you're going to get paid. More specifically, you got 2 different scenarios in terms of how they calculate your raise. Okay, so in both jobs, both scenarios, you start out making $100,000. And in both of them, they're going to give you a raise. In scenario 1, they're going to give you a $10,000 raise per year. And in scenario 2, they're going to give you a 7% raise each year. Okay? And the question is, which deal should you take? I'd like you to pause and think about this word problem. Okay? Pause, give it a thought, give it a shot. Just think about it. No calculations, just thinking. Okay, so maybe you had a strong opinion about this. You were like, one of these is definitely better, maybe not. Some of the ideas I've heard people say before in the past are, well, scenario 1's better. Because after the first year, in scenario 1, you're going to make $110,000. And after the first year in scenario 2, you're going to make $107,000. So in scenario 1, you're going to make more. But that's a little short-sighted, okay? And so what the better answer is, and what I think most of you guys think, is scenario 2 is better. Because although it might be less in year 2, in the long run, kind of like with Desmos, in the long run, this 7% raise is going to end up giving you more money. Okay? I'd like to talk briefly now about some actual calculations that you could do with this. Okay? So if you were going to try and model this first situation, scenario 1, where you start out making $10,000 or $100,000 and get a $10,000 raise every year, you know how to write an equation to model this. Okay? You have a starting amount, a y-intercept. You have an amount that it goes up every year, a slope. This is y equals mx plus b. So if you were going to model scenario 1, it'd be, you know how much you're going to make? Your slope's 10,000, your y-intercept's 100,000. Okay. You plug in 1, after the first year you get 110,000. You plug in 2, after the second year you get 120,000, that kind of thing. Okay. This scenario is the exponential, okay? And we'll learn more about this, but what makes this exponential, the word problem part of this, is this percentage. That's going to tell you that we're going to use an exponential model. Yeah? I'll just kind of show you what the equation looks like. Maybe this will ring some bells or not. We're going to talk more about it, don't worry. But you'd have to say, well, you start out with 100,000. And the reason this is exponential is because, well, first let's talk about how we got this 107,000. I think you guys are good on that. You're going to take the 100,000 and you'd multiply it by 1.07. Why 1.07? Well, 7%, well, that's a percent. I'm going to change it into a decimal by dividing it by 100. And then you don't want to multiply by 0.07 because that makes it smaller. Okay? The amount you're making is going up 0.07, but you're still making the same amount you made last year and 7% more. So the thing you want to multiply is 1.07. Another way to think about it is you're making 107% of what you made the last year, right? Because you're making 100% of it because you're still making the same amount. You're making 7% more. How do you write 107% as a decimal? Well, 1.07. Okay. Now, if you think about it this way, how would you figure out how much you'd make after 3 years? Well, you'd take your 100,000 and you'd multiply it by 1.07. Okay. Oh, and then you have to multiply that by 1.07. Okay. You have to multiply that by 1.07. And if you look at this, what you're doing is multiplying by 1.07 over and over and over. And when you multiply by something over and over and over, that's when exponents become involved. Okay. So how would you figure out how much you made in year 28? Well, you take 100,000, you multiply it by 1.07 to the 28th power. Okay, we're just going to put next in there because we want to write kind of a general equation. So this equation is for scenario 2 for the 7% raise. This equation is for the $10,000 raise. This is linear. It is a line. We have talked about that. You guys know how to do that. This is the new thing we're talking about. It is exponential. If you look at this equation, what makes it exponential? It's got an x in the exponent. If you look at the word problem, what's going to tip you off that it's exponential is that the increasing isn't a flat amount. It's not 10,000. It's a percentage. And so stuff with percentage is going to end up being exponential. What I really want you to take away right now is just that like exponential is different than parabolas and it's different than lines. It's its own thing. And it's actually much more important than those two, I think. Okay, we can pause there. And we'll learn about word problems in depth next. Thanks for watching, guys.